Thank you all for joining. We'll be getting started in a couple of minutes. Just leave the latecomers a couple of moments. So grab a warm drink or something, and we'll get started in a few. I can see people filing in as we speak, so we'll just give it another minute or so and we'll get started. Thank you for joining. Great, we're at 2 minutes, so let's get going. So welcome everyone. This is our third in a series of 3. We've made it to the end, and we're going to be talking through how to do state as an enterprise in Kubernetes beyond the basics. Now, if you don't know what we talked about last time, let's silence that, then please do think about going back. We will be sharing that with you in a moment. But before we get into all that, let me introduce you to my co-presenter, Marcus. So Marcus, do you want to introduce yourself for anyone who wasn't here before?
Sure, thank you, Anthony. So I'm Marcus Leip, one of the co-founders of Miradot. Strong technical background, although my heart is still in the tech part, but unfortunately I'm forced to work more and more in PowerPoint, I believe.
Yes, often gets people. Some very complicated spreadsheets come from these people, I find. Very good. So I'll quickly introduce myself for those who don't know me already. So I'm Anthony Hodson. I'm a cloud native architect. I've had a career that goes from sort of software development through a bit of fintech, managed services, a little bit in DevOps software. I remember standing on a booth and answering the question, what is DevOps? That was always fun. And through public cloud, hyperscale public cloud, and here we find ourselves in Kubernetes land, which is a great place to be. But Marcus, I know a lot of our viewers will have heard of Miradot, but can you tell us a little bit more?
Sure thing. So we started out as a consultancy company that has now moved into the sales of solution world. And most recently, or at least the last 3 or 4 years, we have been focusing on DevOps optimization and integration. So our aim is always to simplify the interaction with IT infrastructure. And we do that by helping customers to get the value out of their IT investments, regardless of it being a new fancy Kubernetes cluster or a Cisco-based ACI network, for example. So we want to help customers work with their infrastructure in a better way. That includes moving all three parts of digital transformation in at the same time, which is culture, processes, and technology. So that's the three areas that we address when working with a customer. We have done a couple of achievements throughout the year. So we became the first Cisco DevNet specialized partner in the world. And of course, we have been focusing on Pure heavily since we became a Pure partner. Where is it now? 2 years ago. As our focus is not only in the infrastructure, but also in the overlaying software, we have Portworx as one of our specialties.
Great stuff. So great to have you involved, Marcus, and Miradot also as well. So if those who haven't been aware of how Portworx and Pure came about together, well, there was a love of Orange, which is always helpful. But about 2 years ago, we were purchased as Portworx by Pure Storage to really up the Kubernetes game that Pure Storage had, right? They could see this was an emerging technology and they wanted part of it. So everything we do will work with any storage at Portworx, but we work particularly well with Pure Storage because we have those integrations and we get to the source code, right? We can do special things there. But I won't go deep into that today. Let's step through a little bit of where we've come from. We had a webinar on the 14th, introduction. You can go back and see that. We had a webinar on the 4th, which was how to get started with State. And then here we are today. Now, all those who attend all of the webinars will be entered for a prize draw to win of 3 heat vests. It's starting to warm up again now, but I'm sure you'll find a use for it going into next winter, or perhaps a cold evening this winter, summer even. We will be drawing that on the 2nd, which gives, well, we'll draw the line for those who have viewed it on the 2nd, and we will be issuing congratulations to those who have won one of the 3 vests beyond that. We will send a link out to everyone following this meeting with a link to the webinars so you can make sure you get credit for that. So speaking of the previous webinars, just a quick recap. Our first webinar, we went into the introduction to data on Kubernetes, things like why we would do that. There's a stat written at the bottom there. The majority of respondents, 83%, attributed over 10% of their revenue to running data on Kubernetes. So this is those who have done it. They've been there and they've now understood the power of running data in Kubernetes. And for me, that is, using the same tooling, enabling those to get to what they want quickly and improving the velocity, which I think is really the theme of this whole series, is that velocity piece. Now, the next session, we went through moving into getting started with State in Kubernetes. So what to measure, you can see over there on the right, that correlates with success, that has a bit of rigor behind it. We've also got the giga-ohm radar there that shows our performance in the market and how we can be trusted to solve these problems. We've got the 7 R's, as AWS calls it, and where the transformation that Portworx can assist with at the top left. And finally, we've got benchmarking versus some open source alternatives. So if you haven't seen it, go back and have a look at that. But today, what I really want to do is talk about moving on to architecting for success, some of the deeper tooling that we have to help you be successful and some of the benefits of those. And I wanted to start with well, I looked at everything that I wanted to talk about. You should have seen that in the invite, and I sort of blocked them up. And the first block of themes, if you will, was safety and risk, right? How do we minimize these things? So how do we architect for safety and success in the organization? Which had me thinking of this chap. I'd not seen the video in full. You can go along and have a look at it. But this guy runs up to people with a camera in their face and says, name a woman, right? And this poor woman's totally taken back, and she struggles, right? She has the she has the time in her mind. Marcus, I think I can hear some background noise, so you might want to just mute. She has the time in her mind to ask if it's an alive or dead woman. That's fine, but she couldn't name a woman, right? And this is because she didn't feel safe, okay? And safety and performance are very linked things. If people don't feel safe with the systems, they don't perform at their best. And this is a theme we see throughout the world, but also in technology. So there's a book called Accelerate. You can go and look at that, and that talks to this. But there's a big body of work around this. So what we want is the ability for our systems to cater for the basic needs of the systems that operate on them, the software that operates on them. Things like, is it going to be available? Can I back it up? That sort of thing. Now, I went through and looked at the major themes that are at risk in an environment, because I do a lot of talking to customers about how we can ensure that systems remain up. As first principle of service reliability engineering is that the reliability of the systems is there. And I've broken down some risks into broader pieces so that we can look at how we can mitigate each of those and where these mitigations come in. So the first one is your destruction of the environment, right? You've got a bad actor. I did see my last company an entire cloud estate be deleted by someone who didn't want that company to succeed, not by the company itself, by an internal actor. They got it back together and that person deleted it again. So, you know, it could be an insider threat, but you need something that mitigates that problem. And I've broken this down into the idea of a remedy, something that is going to solve the problem, and a mitigation, something that's going to limit the likelihood of that happening. A remedy you need for everything, because that's going to be that's where the buck stops. But the mitigations are going to stop that happening. And as in this world where we have trade-offs, often the remedy is harder than the mitigation. The phrase is an ounce of prevention is worth a pound of cure. Well, the cure is a heavier weight thing. So a restore in this scenario from Portworx backup will take a bit longer than nothing happening, because you've got those mitigations in place, but you need to have something like that. The next one is destruction of data. You know, someone drops a table. Did they mean to? Does it matter? It's been dropped anyway. How do we get back to that good state? And that can only really be mitigated with Portworx backup or a backup tool, or something that keeps people away from systems. And there's stuff in the development space that can do that. But you know, it's a bit of out of scope for what I'm talking about here. Ransomware is another one, and then loss of encryption key, which is sort of a ransomware own goal, right? If you lose your encryption key, then you've got a problem where everything you have is encrypted and you can't get to it. So I don't have a solution for that within my suite of tools, but you need to make sure that that one is really catered for, because that could be horrendous. And then on to dependent system failure. As we get into using other people's services, these things are out of our control, or you know, stuff breaks all the time as well. So if you've got say a global provider or a global service, you can mitigate their failures. If you've got a local stretch Kubernetes, for example, you could mitigate a region. So I spend a lot of time thinking about public cloud. So in the scenario of a highly available stretch cluster over 2 availability zones, if one of those availability zones had a problem, you should still be able to keep going. So that would be avoiding local failure outages. But then also these cloud providers, these global service offerings, they also have global outages. And for that to be mitigated, you need to look at maybe using another provider, right? Someone who's on completely different systems, and making sure that you can restore if needed, or you can go highly available with those and combining those 2 clouds, for example. So we also have complexity issues, so things that we've put in that are difficult as well. You know, when you upgrade systems because of security patches and things like that, things change. Have you tested them thoroughly? Is that easy to do? No. Do you want to have good test coverage? Absolutely. Do you want to have regression tests so that you don't get fooled twice, as it were? Yes, absolutely. But there's a limit to what you can do. of course. In this case, you want to have what's called a hermetic backup, right? So you have everything together, those systems are tied down, and then you know that it will come out as it went into this system. But we can also help with Portworx backup as well, which stores all of your data, and you're just pinning those versions of, say, the containers themselves in there as well in those manifests. We can also test things better, make the roll back easier, or the roll forward easier if you've got that strategy, by using mitigations like blue-green deployments and snapshotting. We'll get on to snapshotting in a moment. Well, I see these as a sort of pyramid. So as we saw in that last slide, you've got all the blue ones, all that blue writing is the Portworx backup, right? This is the remedy that applies to all these systems. And then we've got synchronous DR, we've got blue-green, we've got snapshot rollbacks. There's an async DR I've managed not to highlight as well, independent system failure. All those are achieved with the high availability features of Portworx and the migration features and things like that. But that backup, knowing that you've got something there that works, do test your backup, right? Test your restores, and then up to how we make sure these things happen less in high availability using snapshots and so on. And I find that then DR, it can be a smaller piece. Maybe you're just going out to a second site, combining this potentially with that high availability, and you can get very highly available before you go into DR as well. But we'll talk about those things in a moment as well. So just to remind you, if you've seen Portworx, you'll see various Portworx products mentioned. These are the products themselves. So Portworx Enterprise is its own product in orange there. And then we've got disaster recovery, which is an extension to Portworx Enterprise. We've got something called Portworx Data Services for completeness, which is a super tool, but we're not using it within this context. And then Portworx Backup is a standalone tool. So you can get started very easily with Portworx Backup. Indeed, we have a terabyte free management, free forever in a SaaS that you can get started with Portworx Backup. It installs in 2 commands, and we'll show you some demo links at the end. So have a look at that if you've not already. So snapshotting, let me talk to you a little bit about snapshotting. So you can create a snapshot of a Portworx volume. Portworx volume is a persistent store in Kubernetes. So you write data there and it'll stay there. And then in the event of a failure, it will continue to work because we replicate it. In this scenario, we're creating a copy of that data. Sorry, not a copy of that data. We're creating a reference to the data as it was. And we'll get into this a little bit further. In the same way you can do one, you can do many, and we use tags for that. So you could tag everything that has, say, a database and create a snapshot of that for a rollout, or you could tag everything that's associated with a certain namespace or an application or a collection of applications. And this will allow you to do a point-in-time reference on that storage. And the way this works is we just put a pointer into the storage, which we fully manage, we fully control, and we say anything that comes in after this point, we will annotate as being different. Now, this might mean that you replace the same bit of information 100 times, and you would then have 2 copies of that information, possibly 100. I'd have to look into the docs. But we could go back very easily to the state it was in when we put that line out. And this isn't with copying, right? That data is already there. And what this enables us to do is to either accept those changes, remove the snapshot, stop tracking it because it uses up storage, or we can roll back to the point it was before we started. And if you imagine how useful this would be in a failback scenario, where you've rolled something out, you've got some user feedback and it's caused a problem, you can then roll back pretty immediately because you have the ability to go back. Now, you can do similar things with a backup, but in a backup, you're moving data, and this is a complement to a backup, I see. And we see this snapshotting used a lot. If you want to develop this and get to a blue-green scenario, what we can do is we can migrate. There's a module in Portworx called migrate, and this allows you to seed other environments. And the seeding of environments could be for blue-green, it could be for testing purposes, it could be that you want to ensure that you can test on production-like data as well. This allows you to create a copy of that environment that can then be used as a fallback if you want to, or as the basis for your experimentation. And you have to then move your application pointers to this other cluster, or perhaps a namespace if you're not doing it at the cluster level. There are various ways to pull this off, but this is a tool that you could use in your blue-green deployment strategy. Now, I'm going to talk to you next a little bit about how HA and so high availability and disaster recovery interplay with each other, and how I think about this as I look at architecting systems for people. So the first and the most interesting solution that we see in Portworx is a zero data loss between two data centers solution, and we'll get onto a case study that covers who used this and why, and we do see a lot of interest in it. But I want to contrast it to the other approaches. So in this scenario, we have to have both data centers within 10 milliseconds of each other, because otherwise the whole thing has to wait while we could get acknowledgements back. We have two data replicas of your data. As we're splitting between sites, if we had three, we would have two on one site, and that would be a problem because we'd have an issue with quorum. Now, we can do witnesses. This is an important point. When using this scenario, we can have witnesses that are further away in latency terms than if we just stretch the cluster between these. If we just stretch this cluster out, so if we had the blue reaching over that failure domain, then should there be a problem with latency, the whole cluster would be out, which is not an ideal scenario. I'm sure you'll agree. We have the ability to, we must have enough production capacity on each site to run 100% of production, but we could make use of the failover DR site. The compute over there we could use for other things. You're going to need the storage. The storage is replicated all the time, so anything that's over here will be replicated over here, ready to be spun up. But if you have sufficient storage over here, you could be using this for something like UAT or some sort of testing, on the understanding that if you have that bad day and your system needs to fail over to this second site, then you kick UAT off. And I've definitely spoken to organizations who believe that is completely unacceptable, and other ones who think, yes, this is a great way of saving money, because we don't necessarily want to leave computers sitting around turned on, not doing anything. So that's our Metro DR. The way I would contrast this is with stretching a cluster. So if we have three clusters, of course, when you have three and you lose one, you only lose 33%. If you have two and you lose one, you lose 50%. So the overhead you would need to provision is less. And we see that here. This is also somewhat fully automated by Kubernetes, right? All of these sites are the same. Portworx then automates the moving around of the storage and the replication of that, and we can have three replicas in this scenario. You could have 4 availability zones if you wanted. We tend not to see that in public cloud. They tend to stop at 3. But you could, but you would have 3 replicas of the data moving around between those clusters. If the latency gets high, as I said, the cluster stops working. That's something to consider. It must therefore be very reliable, and reliable under 10 milliseconds. And when I contrast the two of these, here's how I tend to think about it. Now, the 2 data center model has been around a very long time. We see this in a lot of customers who do on-premises themselves, and I tend to see Metro being used in those scenarios. So I would use Metro if network consistency is of a concern. Often you have arrays backing the storage. Those arrays have resiliency built into them as well. In fact, you can get resiliency on resiliency on resiliency if you're not careful, and that can use quite a lot of storage, because you could have RAID 1 on the disks, you could then have RAID, well, not RAID, you could then have replication of virtual machines, and that can double it again. And then you could have replication of Portworx volumes, which could double or triple it. So you want to, when you're architecting, think about where you're doing replication, because you might be able to free up some of that. So that's the Metro. That's when I would use Metro. I see that more typically on premises. And then we move to multi-site high availability. I see this more in public cloud. You can also, limit those failure domains. You can have more failure domains, which is nice. And if you want to use Portworx data services, using this multi-site HA across 3 works really nicely. Now, if your clusters are further away than 10 milliseconds, right, the speed of light is a real constraint, and we call it metro, by the way, because they tend to be in the same metropolitan area, so about 50 kilometers maximum. You can use async DR, so an asynchronous replication over to another site. You can mix and match some of these, and if you want to talk about that, get in touch and we can talk you through it. But in this scenario, from version 3 of Portworx, which is coming out in the next month, we will be able to limit your data loss to under 24 seconds, assuming that the latency is under 150 milliseconds, which on infrastructure-based links should get you between any 2 points on a blue planet. But you've still got 24 seconds of data loss up to contend with. So people would rather not lose data, but sometimes it's necessary, right? We also have the 200% peak prod needed in this 2 data center scenario. And we can do either an automated failover or a gated failover if you prefer, because systems have to point to their DNS needs to update, things like that. So you might want to have a go, no-go decision. And in this scenario, we would have up to 6 replicas of your data if you set 3 up in the original site and 3 in the next site. That gives you a nice safety net for your data being available. So if we contrast those 2, Metro and async, just so you can look at how they work, you can see in the top one, we have a stretched Portworx cluster. So 2 different Kubernetes clusters, but with 1 stretched Portworx cluster. Whereas in the bottom one, they are separate installs, and we are just replicating the Kubernetes objects and the Portworx data over between them asynchronously. So the client who we developed the Metro solution with is Royal Bank of Canada, and this was their brief, right? They wanted 0 data loss, so a 0 restore point objective with a less than 2-minute failover in the event of an entire data center outage. And as far as I'm aware, people can correct me, we're the only people who can meet this need. So it's a very interesting prospect, as long as you've got the infrastructure set up in the right way for that. And now you understand how to do that. So I want to get on to efficiency and how we can make your lives easier by using Portworx, and the efficiency for green things and everything else, right? We all would like to save something. So IBM state that by using Kubernetes, containers, you can reduce 75% of the annual server maintenance, administration, and facilities costs, right? You can drop the costs you have associated with your IT. You do have to get these things there first, and that might mean picking them up and doing something smart with them. But in another way of saving on cost, bare metal is coming up more and more. So this is a report by Equinix. They've been writing about this, but it's borne out in what we talk to our clients, because we do see people moving towards bare metal, where you would get 10 to 20% more node level resource if you move to bare metal. Now you've got to think about this, because you probably need to have a scale where a large server and several large servers running your Kubernetes as their own blast radius come into effect. So that tends to be bigger installs, but you can save some money by doing that. The benefit of having more resource at the node level is great, but also the benefit of not having to pay for your hypervisor can be a big needle mover as well. So we see that. Now, We have some automations as well that are going to help remove the need for you to do work in your teams, which would allow you to do something more valuable with your time, right? Solve other things that are slowing your velocity. So we have Pure Storage is automated provisioning onto our storage. I mentioned that we have better integrations there. Those go to FlashArray and FlashBlade. Nice integrations that take care of that. We also work closely with public clouds, so we can automatically provision disk into AWS and GKE, and we'll get on to another tool around this as well. And then private cloud, if you want to automatically provision into VMware, whether that's Tanzu or vSphere, and get disks automatically provisioned. We have seen people run out of storage without these things, and someone missed a ticket and there was some toil, as you'd say in SRE, to get this fixed. It didn't get done, and then there was an outage. So this is the case, one of those cases of automate it and forget about it, right? I'll take care of it. Now, these are coming up backwards. Let's go back there. Where are we? Right, we also have a product called Autopilot. There's supposed to be a nice image there. Maybe you can see it. Let me see if I can. No, I can't see it at all. But basically, Autopilot is an iteration, a development of what we just saw with the automated provisioning. But now it expands pools of storage and the drives themselves. And it also moves around the replicas underneath the storage to remove the need for you to do that. So if you're looking at removing more work, maybe have a look at Autopilot, you can set up schemes, rules that you execute when you need more storage, and it's all monitored through Prometheus. So you set up those levels and alerts. So as you look at doing this at scale, this will remove work for you. Apologies, that slide didn't come out. So there's also integrations we have into other platforms and also other security vendors. So when we are encrypting volumes, which we can do at the volume level or at the cluster level, which opens up multi-tenancy. Right? If you want to do this, if you want to issue a Kubernetes platform for many users, it's important to make sure that your disks are encrypted so that no one can read anyone else's data should they get to that block store. We have secrets encryption, secrets sharing with the providers you see there. HashiCorp Vault is the one we see most. I suspect Kubernetes secret store is the one that happens next most, but HashiCorp Vault have been doing very well in this area in recent years. And we have also the ability to do, through a product called KubeVirt, a hypervisor style activities. So you lay down a Kubernetes, maybe you probably want to lay that on top of bare metal, because otherwise you'd be virtualizing on virtualizing on virtualizing. So bare metal, Kubernetes, and then you can do KubeVirt. Now KubeVirt is able to take care of this, but it is early in this journey. So it's 0.5 is the version of KubeVirt that's currently used. My first question is, does it do Windows? And it certainly does. I wonder if that's also your question. But it's worth a look. But if you're very used to VMware and comfortable with all that tooling, you might find this is a bit scrappy. But we do see people making use of it. Right, the next thing is factors for cost savings, right? So how do we model the benefits that you might get from using Portworx, from moving to containers and speeding up that move? So we've got the microservice management efficiency, so you don't have to solve certain problems that are involved in the running of containers if you're using persistence and Portworx is underlying there. So you can then move things in easier, that you need to do less architecting to get those in. You can also avoid cost outages through the high availability features. You might want to look at your old data as to how often those things happen. An interesting one we had for Audi was that they wanted to thin provision in public cloud. The public clouds don't let you thin provision. They also limit you to the number of disks you can attach to hosts. This means that you might have more hosts than you want. We can avoid those issues as well. You can, as I said, save, you can use DR, your DR site, as an active participant in your estate, doing something like UAT testing, and your operational teams would be able to do other things other than doing this toil that we've seen. We've talked about license saving from bare metal. We've talked about the optimization in node level performance through that as well. We've got containerization generally saving you money on that IBM statistics. And then finally, and importantly, those who do data on Kubernetes, which we talked about right at the top, they see 10% plus in growth in the organization, improvements in revenue, I should say, through doing data on Kubernetes. That's what they put it down to. So that could be a very big number as well. Now, modeling all of these things is more art than science, I would say, but here's how I would start to look at this, and we're happy to help you with such things. So you've got to consider how long you're going to be modeling for, how many monolithic workloads you've got, how many virtual machines on average that equates to, how many of these you're going to leave behind because they're not worth the work, and what the footprint is that you expect to achieve, and that's an IBM statistic there. And then we can estimate, all the text in red is a calculated field, by the way, here. We can estimate the number of monolith VMs, and we can estimate the microservices in scope and so on. And it gets us to thinking about also the speed at which we can migrate to achieve those savings sooner by using Portworx. So if we look in the top right, we can see the reduction in effort needed when you have an application consistent DR built into the platform, right? How much work does that remove from your teams who would otherwise have to solve that problem? How much work is removed when you no longer say to the application developers, well, the need to do backup is on your shoulders, and instead you can say the need to do backup is built into this platform, and by the way, I've set you up a schedule and it backs up twice a day. Here's how you can log into the system to restore, right? How much work does that remove? And then the reduction in effort when the system's persistent storage is taken care of, right? And you don't need to highly available it at the application tier. How much of effort is removed there? And all this equates to an estimated build-up of velocity that gets you in. And then you can build all those things into a model based on, how much an engineer costs, how much do you pay your engineer, how long are the sprints, and so on. And you start to get to a really meaningful amount of money there down the bottom on a relatively small estate through the reduced engineering effort alone. And that's without even considering the savings from getting to that destination sooner by compacting your estate down. So this as a business case does build out very quickly, and this doesn't even take into account those other pieces that we saw, through, say, thin provisioning in cloud, for example. So there's a lot you can work out, but it's a very specific thing for your organization and your goals, and also how you are measured in your teams and how those who are helping you with this want to see their stats come out as well. But it's something we can help with if it's helpful to you. So I promised in the brief that we would also talk about the emerging themes, and here's my take, and Marcus will add anything, although we did talk before, so some of his are in here. I see that environments are being standardized, so there's not a difference between this cluster and that cluster. People don't want to have a poor man's cluster and a poor person's and a rich person's cluster, right? They want to make all of the features available to all of them, so that you don't get this imbalance. So they're looking to do that. We see a want for multi-tenancy, but with the ability to do multi-tenancy comes the requirement to do chargeback, because if we don't charge people for the things they consume more, and that goes against some of the goals that we've got here. And then we're seeing bare metal at scale. We've sold a lot of bare metal licenses because people, particularly enterprise, are seeing the benefits of this, right? That 20% is a big jump in capacity performance, which saves quite a lot, right? Saves a lot of networking gear, saves a lot of compute, saves some storage even as well. So there's a lot of savings to be had there. Let's click it on. We're seeing Google Anthos pick up. A lot more of our clients are starting to use that. And also this idea of repatriation. So things that went to public cloud are coming back, or they're spanning the two. Although we do also see traffic going in the other direction. So I think people are settling on this hybrid world. Did they ever not have a hybrid world? I don't know. Maybe it was just a goal they had, but we see a lot of that. I've mentioned DevOps, SRE, and platform. Platform is what I'm seeing most teams be called that are interacting with Kubernetes, and this idea of platform being king was a big piece of the KubeCon, which was on last week in Amsterdam. We see that developers are waiting for Kubernetes to come through to have somewhere to put these things, because they're already developing applications in containers. How do we make them work for this in production in a way that is slick, right? How can they use their pipelines and things to get those things in there? And then we see a lot of traditional vendors entering this space as well. So Kubernetes Backup is a good example of that. They'll all do that. You've got to make sure that you've got your tests in place and check to see how easy these things are and whether you get that application consistent restore. Think of it as a whole picture. How hard is it to recover in those scenarios, rather than just saying, oh, the incumbent says they can do it, let's sign up. I'm sure you're all more discerning than that anyway. We've seen people moving away from Tanzu because of the Broadcom purchase, and Broadcom have historically tightened the screws on the costs. So we see that being a concern and a little bit of a move, and this might explain some of that bare metal as well. Red Hat, OpenShift, we've seen good growth in those areas, and we've seen on the same theme ODF, the Open Data Foundation, which came from Red Hat, has moved into IBM. And this, where anytime you change anything, it makes people a bit uncomfortable. So a little less traction on that. We are seeing that, well, do you want to talk through these last two, Marcus? Because I think they were your pieces there.
Yeah, so what we're also seeing is that the reality isn't that you can do just remodel all your applications to become stateless and put them on in Kubernetes. So we're definitely seeing more stateful application being migrated into Kubernetes. And along with that, you want to get rid of those old VMs or even physical servers that run your databases and put them as a service into Kubernetes. And of course, Portworx Data Services has a offering for that makes it super easy to spin up a new database of your choice in a Kubernetes cluster.
Great stuff. Thank you, Marcus. So this is a slide we saw in one of the previous sessions, but if you want to jump into some of these technologies and how they work, there's some very small demos there that'll take you through it, and in the time it takes to drink a warm drink. We've got Portworx. Portworx can be trialed from central.portworx.com. Most of these products will be available as a SaaS this year. That's a way we're moving. We're keeping the on-premise options alive as well, of course. There's a lot of our business that's dark side, but you can try these there. Get in touch if you'd like some help. We can get you to that starting line a little bit easier. But most of these can be installed into Kubernetes in 2 commands, and you can get started with those. Portworx Data Services, our database as a service offering, ever-increasing number of applications that are supported in there, so learn more there. And if you want to see what analysts think of us, there's a GigaOM report there that you can have a look at and see how the market shapes up in an impartial way. I think that's it. So we've had 3 webinars. I thank you all for attending, and we will be drawing those vests next week. We'll draw the line and then we'll draw those vests next week. I think there's just an option for some questions, although I don't see there's a question slide. So if you've got any questions, now's a great time to talk, but otherwise keep in touch and we can talk offline. Or just watch the chat for a moment or two. Very good. I think we're clear of questions at the moment. Yeah, that's it. I think we're bang on time, right? So it's been a pleasure talking to you. Thank you for listening. And do feel free to connect with Marcus and myself. And have a great rest of the week.
Thank you for attending.
All the best, everyone. Thank you.
Bye-bye.